FOSS Active Investigation is more than hands-on science. It is how science becomes accessible for all students. Students use science and engineering practices and cross-cutting concepts to construct explanations about real-world phenomena. These are the components of active investigation, although they don't always follow the same linear progression. 1. Context: sharing, questioning, and planning. 2. Activity: doing and observing. 3. Data management: recording, organizing, and processing. And 4. Analysis: discussing and writing explanations. To establish context, students share prior knowledge about a particular phenomenon through a discussion. Generally, a focus question is introduced. Students might plan a method to investigate the focus question, or one might be provided for them.
I claim that this is a fruit. So talk with your group, okay? How are you going to support that claim? Do you agree? Do you disagree? What's your evidence?
I claim it's a fruit because it has seeds and some, I don't know if it's a fruit or not, because some fruits, I don't even know if it's a seed or not.
It has a seed, because when you bite to it all the way in the middle, it's literally a seed.
So I heard a lot of great discussion. You were right. This fruit is indeed a part of a plant. All right, but let's talk about the characteristics. Let's talk about the characteristics of this apple. Characteristic is anything that you can observe. So the shape, the color, the smell, the texture.
Get a piece of the apple. You bite a bunch. And you might get a piece. And yours is darker. Yeah, mine's darker, she's lighter, and yours more lighter. That's like.
Now that you guys are a little bit more familiar with characteristics, I'm going to give you a bean pod.
During each FOSS activity, students conduct the investigation, often in collaborative groups. They observe their first-hand experiences with objects, organisms, and materials. This provides a common experience for all students.
It smells good, but then it smells bad. Okay, I finally did it.
That has a characteristic. It looks cool. Green cheese.
What did you find inside? All right, good. So you guys just opened up a fruit. And what we know about fruits is all fruits have what?
Seeds.
Seeds.
I got 7 seeds. I have 3 seeds that aren't broken and are big.
Observed data are recorded in science notebooks while students are working with materials. Some data need to be organized in a way so students can see patterns or cause and effect relationships.
So you've counted your seeds, and let's focus on the characteristics of that bean seed. All right, in your notebook, go ahead and draw a scientific drawing, okay? Make sure it's accurate, big, colorful, detailed. Make sure it's labeled.
What if I ate one of these first?
And then can you label? Put this up. And then you can draw a line to show that that's what that is. All right, we're going to use this to make sense of the number of seeds I have. So I'm going to call you up, and you are going to get a dot. And with this dot, you're going to put it wherever number represents the number of seeds that you have. So if you had 6 seeds, you're going to put a dot here.
The most important part of active investigation is extracting meaning from data. This is done with students rather than for students. It requires student analysis, logic, discourse, prior knowledge, and scientific communication. Students explain phenomena, ask additional questions, answer the focus question, and provide evidence to support their thinking.
What patterns do you notice about this graph? Talk with your partner.
Like the middle is like 5. To be 2, and then the red is 6, so they were 2.
What was the least number of seeds in a bean pod? Talk with your partner.
3.
All right, what was it, class?
3.
3. The question is, what was the highest number of seeds found in a bean pod? 9. This was the highest number of seeds found in a bean pod. What is something else you noticed about the data? Talk with your partner.
6 has the most beans in it.
And 3 has the least beans in them, and 6 has the most.
Does anyone want to share what they talked about?
6 had the most beans and 3 had the least beans.
There's a tie between 4, 5, and 9, and 6 has the highest seeds in it.
There's no beans in one.
If I were to open another bean pod, based on what we found today, how many seeds do you think would be inside?
It would be 6.
Why?
Because almost, like, I guess everybody got 6 in their pods, so it's most likely for you to get 6. Me and my partner were talking about, like, it would probably be 5, 6, or 7.
And why did you guys say 5, 6, or 7?
Because there's higher chances between 5, 6, or 7.
There's higher seeds.
Like, there's more people that got 6.
Oh, there's more people that got 6.
The investigations guide for each module is designed to support students' thinking through all aspects of active investigation, with detailed instructional supports for the teacher.